place it there. Okay. Okay, so I'm going to present this work, Exploring CyBOK, which I think all of you might know, with topic modeling techniques. This is a joint work between myself and my colleague, Mohamed Rashid, and Isabel I am Isabel González Tablas from Universidad Carlos III de Madrid, which is in Spain, Madrid. Okay, not here, here, no. Okay, I found the right button. Okay, so all of you also know that there is an ongoing cybersecurity professional shortage, and there have been great efforts in the last decades to provide grants to cybersecurity education, training, and talent management. In this slide, you can see some of the most prominent ones. There is the set of NIST frameworks. This is a cybersecurity workforce framework, but they also have a great experience providing certifications to education courses. And we also have UK's related frameworks, the skills framework, together with the knowledge task all together, which also has associated certification degrees program. And we also have the joint task force effort developing the cybersecurity curricular guidelines. These are more recent. And lastly, we have the cybersecurity body of knowledge. All of these efforts are very interesting, and you have to take into account that they are different in nature and in purpose. And well, this is the one that we are going to focus on, and it's special because it's literally a textbook, which is different. Well, not a textbook, but you can read it, and it's different from the other frameworks, which are mainly or mostly a list of elements. Okay. Well, this scenario has been addressed in the research area because there are several frameworks different. And for example, here in this paper, they're trying to compare how these different frameworks address the different cybersecurity skills. I don't see it very well, but they differentiate between technical, management, and so on skills. There is also this other paper, there are more than these ones, but they are very good examples, in which they discuss what do we mean when we speak or we say cybersecurity. And this is an important question because all these frameworks and specifications have in mind some concept of cybersecurity, and we as professionals have to make sure that we understand between ourselves if we want the people follow what we want to recommend and so on. Okay, and lastly, there are also efforts that try to get resources, educational materials, or job postings, various things, and try to map these elements into the frameworks. So in this work, these two previous works are from 2021. This one is older, it's 2018. And in this work, they are trying to map some of these curricular frameworks into CyBOK, and with this, well, categorizing some of the topics in the 5 categories that CyBOK contains. Okay, so if you're interested in this area, please have a look at them. So this is our research motivation. These research works have been done mainly manually or using assisted tools. Okay, for example, in the case of this aspect, I'm referring to the mapping framework included within the CyBOK, which is very interesting, but it still requires both tasks, significant time and knowledge of the resources. So this might be a problem because there are a number of cybersecurity related resources. So our question or research problem, is it possible to provide some supportive tool that helps to partially or fully automate these tasks? And this is what we want to research. So now I'm going to introduce you this discipline, which is text mining. In this discipline, I'm to take texts, mainly text documents, and analyze this information using a bunch of disciplines. You can see them at the bottom of the slide: artificial intelligence, statistics, machine learning, and natural language processing techniques or computational linguistics. So it's very useful because there is a lot of unstructured or semi-structured information there in internet or in our computers. And this type of techniques can help us to analyze and understand these texts. More interesting when there's huge volumes of information. So usually these techniques start by collecting data. Then these sources are reprocessed and cleaned because there is some information that is not useful and it's going to make more difficult the analysis. And then after we have this process done, we can start the analysis and knowledge extraction. We have several text mining techniques. I'm going to focus on text categorization and topic modeling, which we are going to detail a little bit afterwards because it's the one that we have used. But I want to highlight the difference because text categorization takes a bunch of tests and you need to have a clear categorization defined, and you need to have a ground truth for a set of these sources. And then you train a model, and you can give new samples to the model, and the model tries to categorize the new samples in these existing categories, okay? Topic modeling is a different machine learning technique, and it's unsupervised. And this means that you don't have to provide the model with any information. You just have to provide the tests, and the texts are modeled, and then similarities are seeked, and they provide you some result. You like it or you don't, okay? But it's automatic. So this is the model, the technique that we have used. Okay, so what about text mining in cybersecurity? Text mining is widely used, well, mainly not widely, but significantly used, but not for the purpose that we seek here. Usually, text mining is very useful in activity monitoring and automatic detection of threats, attacks, and other cybersecurity events. Here you have a survey, if you're interested. And regarding topic modeling, it has been used to identify main topics in online communities, to support data leakage prevention, to identify the topics in a document, or to analyze time evolution, vulnerabilities and threats in regard with the National Vulnerability Database or CyBOK, okay? So, but it's not one of the most widely techniques. Regarding the specific focus of our work, we have some preliminary works from 2021. These are the only ones that we have found. There is an exploratory work on text classification. This is the other technique I mentioned, of cybersecurity training curricula, trying to map in these curricula, these short course descriptions, to work roles of NIST and ICE framework, okay? But this work uses basic machine learning. It obtains, well, medium results. needs further work. And there is also another work related and funded by CyBOK, in which these researchers try to map PhD thesis to CyBOK. Okay, but this is very difficult. They give a few details, very difficult because these documents are very large and it's difficult to extract the topics and without a ground truth. Okay, so it's also a preliminary work. Both of them notice that they focus on text classification, not topic modeling. Okay, so this is our research problem, and this is our first work addressing this problem. So we have focused on the first task, analysis of cybersecurity frameworks. As this is our first work, we selected one framework, which is CyBOK, as is text book. You can read it. It's easiest for machine learning algorithms to understand the content, introduce semantic information in the analysis. And we have selected this text mining technique, topic modeling, because if we would like to apply text categorization, we would need a ground truth data set, which we don't have an extensive one. So our specific research question is it possible to build a meaningful topic model of CyBOK? This means that we are going to find latent topics using a topic modeling algorithm. We tried two algorithms. The first one of them didn't provide nice results, but the second one is the one that is presented here. And then we analyze if the topic model makes sense, because topic models can be analyzed in a subjective way. It only makes sense for an expert. You can analyze if the topic has nice statistics, characteristics, but only an expert can analyze if it fits really the data set. So what is topic modeling? A more detail, and which specific topic modeling technique we have used. So as I told you, we start with a bunch of documents, and then the topic modeling techniques derive a set of topics, and they characterize each topic with a set of words, which are specific to that topic. Usually, you can find the model, the result also includes one very important result, that is the labeling of each document to one of the topics, to at least one of the topics, because we have other topic models that may assign different weights, so you can find a relation with a document into several topics, or you can extrapolate this relation. We have used BERT topic as topic modeling algorithm. It's very new proposal, and it's really nice because it incorporates the state-of-the-art language models based on neural models. It's unsupervised, and the most nicest characteristic is that it provides an open source Python library, which works as hell. Okay, so this is also very important. So how does BERT topic work? So this is somehow a framework, so you can substitute each part with other algorithms, although the framework, the algorithm has its preferences. The first part is modeling the documents. So in this case, each document is transformed to a numeric vector representation, which is very dense. So it doesn't have zeros. They try. This representation is done with pre-trained language model, and this is where the tricky part comes, because I think this is the key of the nice results. Well, we think that they are nice. We obtain, and maybe the difference with using a basic machine learning, because these models, these representations are trained with large data sets using neural networks. They're really, really state of the art, and they are getting really promising results in a lot of areas. So we specifically use this language model, and it's not very heavy because it doesn't obtain these large vectors. I think it's 382, it's the half, so it's quite quick working. So after you transform the documents into this representation, and you also have to consider that they incorporate semantic information. It's not the same, the word mouse, as this mouse of the computer, as the word mouse. They are capable of differentiating similar terms, incorporating their real meaning in context, okay? So once we have the documents, the algorithm reduces the dimension of these vectors to the bare minimum, so it's easier to proceed with the next steps. Here, for example, we have 3D representation of Earth cities. And we have here reduced one dimension to 2D. And here we have afterwards a clustering of the resulting vectors. This clustering algorithm is density-based. So this means not only the instance is used as an input, so you can get shapes, weird shapes. Okay. And here we have this clustering, this hierarchical clustering. This clustering is soft clustering technique, which is important because something I tell later if I have time. Okay, after we have these clusters, here we have the documents, which are grouped in similar, using similar, semantically similar documents. There is the step that finds the representative words of each cluster. In our case, the clusters are the topics. Okay, and there's this option, and we have not used it. We have mainly used default parameters, so it has been quite easy. And the only important thing is that we have used the possibility of computing the probabilities. Okay, the clustering technique assigns each document to one topic, only one, or to void non-topic, okay? But there is also the possibility to compute the probability of finding any of the other topics in one document. So we have put this option to true, so we can assess how far or close each document is to one topic. Okay, we got how did we build our corpus? We got all the chapters of CyBOK, the PDF. We transformed them into text-based UTF. We removed some sections, and then we established each of the paragraphs as a document. So we have worked on a paragraph basis. At the end, we obtained around 5,000 documents. This is what we obtained. Each of the chapters has a nice number of documents. The smaller number is in the introduction, and the largest in law and regulation. This is the distribution of the number of documents found in each chapter. The length distribution, not the number. So most paragraphs are around 500 words, okay, in length. So this is our result. This is what you obtain from topic modeling algorithm. We obtained in the first branch of the algorithm around 50, 51, 52 topics. We tuned a little bit the parameters, but the results were more or less coherent. And you can see here, this is the topic where the documents that do not have any topic assigned are placed, and the rest are meaningful topics. And for example, we can have a look at topic 0, which has 10 words representing this topic: malware, criminals, malicious, victims, botnet, crime online. Okay, I think all of you can identify which topic is. So this is the first 26, and these are the next 26. Most topics are meaningful from our point of view, which we are not high security experts, but we know something about cybersecurity. There are some weird topics. You can see these are rests of text that had not been cleaned, and this is also some kind of weird. So there's a need of further work. This is how the clustering looks like. Some of these associations may not make sense because we have to take into account that we have used a language model that is not cybersecurity focused. So maybe from the point of view of the language model, there are topics that are related, but we don't understand that as such, okay? So remember I told you that you can ask the model to output these probabilities, okay? So we have analyzed this part, and this is what we obtained. This is for all documents, the 5,000, 2,000, whatever. This is a probability distribution of finding any of these topics in the documents without outliers. Okay, notice the range of the probability, which is very low. So most of the documents present a very low probability of finding in them the topics. Okay, so if we analyze the outliers, we see that there are documents, a significant number of outliers, and are these circles. And notice that here the range of the probabilities go from 0 to 1. Okay, so we made this analysis. Most documents have 1 or 2 topics assigned with a probability larger than 0.05, which is really low, but larger than the normal range. We analyzed also how these probabilities were distributed per chapter. So we selected the documents, the paragraph in each chapter, and we analyzed how the probabilities were distributed. And we found 3 cases. There are some chapters that have 1 or 2 predominant topics. You can see it here, chapter 5, which is privacy and online rights. And this huge peak is topic 2, privacy, data users, information technologies, which makes sense. There are other chapters that have several frequent topics. And there's a special case of chapter 1, introduction, which is good. Okay, so you can look at the details in the paper if you're interested. Mainly the identification of topics seems reasonable, and there are some unexpected results, only 1, okay? We analyze each of them. Possible expansions and limitations of our work. Okay, this is a first step in a possible research line, I think very promising, and that would benefit users of cybersecurity frameworks. If not intended as a substitution, but as a supportive tool, okay? So this has to be clear. And the possible expansions in midterm, next, we are already working on some events to apply topic modeling techniques to several frameworks at the same time to compare the contents, the overlapping of these frameworks, and research other text classification techniques that incorporate this new neural-based language model to support finding these relationships between cybersecurity resources and the frameworks. Our results are promising, at least regarding to CyBOK, because the topic model looks reasonable. Limitations of our work is still room for improvement. As you have seen, there are some details, and mainly as the language model is not cybersecurity specific, there is no one of this type. Well, this is a limitation, intrinsic limitation. So we think we obtain a nice topic model quite easily. The results pave the way to several interesting expansions. We have specific future work, short term, but we are more eager to start with these extensions, which look from our point of view very, very interesting. And that's it.